Hello everyone. Now let's solve this complex rational indicial expression. Now we have 2 exponent n plus 3 multiplied by 3 exponent 2n minus n times 5 exponent n plus 3, okay, multiplied by 6 exponent n plus 1, then all over this, okay. All right, now the first thing we need to do in order to solve this problem is to factorize the numbers. Okay, we factorize them into prime factors and then add powers of the same base and get results. That is, I'm going to factorize 6. Okay, I'm going to factorize this into what? Prime factors. This will also be factorized into prime factor. 10 will be factorized into prime factor. Same as what? 15, because 2, 3, and 5, they are prime factors. All right, so which means the first thing I'll do is I'll write this again. That will be 2 exponent m plus 3 multiplied by 3 exponent 2m, okay, minus n, multiplied by 5 exponent n plus 3, multiplied by, this will be what? 2 times 3 raised to the power of n plus 1, all over, this again will be what? 2 times 3 raised to the power of m plus 1. Then this will be 2 times 5, because 2 and 5, they are prime factors. 2 and 3, they are also what? Prime factors. Then this will be raised to the what? N plus 3 multiplied by, this will be 3 times 5 raised to the what? Power of n, because 3 and 5 are also what? Prime factors. All right, so in this case, this will become 2 exponent n plus 3 multiplied by 3 exponent 2n minus n multiplied by 5 exponent n plus 3. Now then we need to expand this. That will be 2 raised to the what? N plus 1 multiplied by 3 raised to the what? N plus 1, all over. Then this will be 2 raised to the what? N plus 1 multiplied by 3 raised to the what? N plus 1. That is when we use expanded rule for power of the product of exponents. All right, so in this case, we have 2 exponent n plus n times 3 exponent n plus 1, then 3 exponent n plus 1. Then also this will be 2 exponent n plus 3 multiplied by 5 exponent n plus 3 multiplied by 3 raised to the power of n times 5 raised to the power of n. All right, so we are now going to add powers of the same base. Okay, so same base in this case for the numerator, the top, we have 2 exponent n plus 3. Okay, then we add it to this. That is n plus 1. We had powers of the same base. When multiplying with exponential notations, if the base are the same, then we add the powers if the base are the same. So we do the same thing for base 3. That will be 3 exponent 2m minus n plus n plus 1 multiplied by 5 exponent n plus 3, all over. In this case, we combine this. This will be 2 exponent n plus 1, okay, plus n plus 3 multiplied by 3 exponent n plus 1, okay, plus m multiplied by 5 exponent n plus 3, then plus n. All right, okay, so now we can see here that this is 2 exponent n plus 3 plus n plus 1. And this is the same thing here. So we have 2 exponent n plus 1, just like what we have here, plus n, just like what we have here, then plus 3. So this will cancel out, all right? So this will be minus n plus n. That will be 0. So we'll be left with, for that, we have 3 raised to the power of 2m plus 1. 2m plus 1, okay, times 5 raised to the power of, that will be m plus, also we have m plus n plus 3, which is as the exponent of 5. This also will be, this also is what? 5 raised to the power of n plus 3 plus m. So this will cancel this. So we'll be left with 3 exponent n plus 1 over 3 exponent n plus m. That will be 2m, okay, plus 1, plus 1. So when this cancel this, then we'll be left, the answer will be what? 0. So we just solve this complex rational indicial problem. The noblest pleasure is the joy of understanding. Bye-bye.